Okay, the law of cosines is slightly different from the law of sines, and we're going to explore the differences between these two later, but for now let's just jump straight into it. First of all, there are three different formulas for the law of cosines. I want you to realize how very similar they are in their structure. First of all, let's focus on the third one. That third one right there, if we were to take out a piece of it, let's cover up a couple things right here. If we take out that right there, what does that look like? Boy, I hope you were thinking about the Pythagorean theorem. But see, since these aren't necessarily right triangles, we have to throw this part in here as well. And we could do this for any corner, any angle, anything like that. So we have three different formulas depending on what we're dealing with. So for number 18, it says find the distance between the trees from number 8. This goes back to the previous lesson. And the picture that we drew for that looked like this. I'm going to take the trees out of it, and we're going to have an A here, we had a B here, we had a capital C here. I believe this was 10, this was 12, and that was 24 degrees. Obviously this is not drawn to scale. And then it says find the distance between the trees from number 8, and that would be this right here, because in the original picture I had a tree there, and I had a tree there, and I didn't choose to draw it here because I didn't want to clutter my picture up. But we're looking for this measurement right here, and that's little c. Okay, so let's stare at this for just a second, take note of what we have and what we don't have, and we'll make some notes about it as well. We have big C. We don't have little c. We don't have big A, but we do have little a. We don't know big B, because that'd be an angle measurement that we're missing, but we do know little b. Okay, let me give you a hint. Whatever you're looking for is the formula you'll pick. Let me tell you what that means. I'm looking for little c. Pick the formula that starts with C. If I was looking for little b, I'd pick the formula that starts with the B. If I'm looking for little a, I'll pick the formula that starts with an A. If I'm looking for big A, I'll pick the formula that starts with an A, regardless of whether it's upper or lowercase. We'll talk about that later. So, here's the formula we're going to use. C squared equals A squared plus B squared. Again, that looks awfully Pythagorean. Minus 2AB times the cosine of C. Before we get any deeper into this problem, I want to point out, just in case you're doing this on a different day, and just in case someone's reset your calculator, let's get in this habit again. Press mode. Make sure you're in degrees. If you are not, you need to change it to where you are. Second and quit. Okay. Let's start filling some numbers in. And we're going to leave out what we don't know. Now, we do not know little c. Okay, so we're going to put a little c right there. And he's squared, because that's the way it is in the formula. And that's equal to little a squared, little b squared, minus 2 times a times b times the cosine of c. This problem looks like a mess. It's much easier than you think. Much easier than you think. We could simplify and solve this in pieces. We could simplify it in pieces and then solve it. I believe at this point it would be perfectly okay to do the whole thing in the calculator. I want you to realize, too, what you're looking for before we pull out the calculator. We're looking for C. C is already pretty much by itself, with the exception of that exponent. C is by itself. All we need to do is type all the stuff right here in the calculator. So let's do it. 10 squared, that's 100, but we'll just type it. Plus 12 squared, minus 2 times 10 times 12 times the cosine of 24. There we go. Once I hit enter, obviously I'll get my answer. Now, that is not my final answer. Totally not my final answer, and I'm going to explain why it's not. C squared equals 24.75. There's two reasons why this is not your final answer. First of all, we haven't found C. Ignore that bell. First of all, we haven't found C. We found C squared. Now, you know where to go from here, I hope. You're going to have to take the square root of that. But I want to put this in the context of the problem and help you understand why this, aside from the fact that that's an exponent sitting there, aside from that, I want you to understand why this wouldn't work. If you go back to the original problem, which was number 8, it says that you have 2 trees and you're going to tie a rope in between them, and the rope is 22 feet long. The distance between the trees can't be 24 feet. If you have a 22-foot rope, you can't tie it between 2 trees that are this far apart. So when you put things within the context of the problem, sometimes you can figure out if you're right or wrong with your answer, or at least if it's reasonable. So, I believe you know where we're going with this. Let's take the square root of both sides. So we will take the square root of our last answer. I'm a 2 decimal place kind of guy on these sorts of things. So 9.47, 4.97, wow, I read that wrong. 4.97, very close to 5, 4.97, and the original problem was in feet. We just found the distance between the trees using the law of cosines. Now, notice that this is very different from the law of sines in its structure. The law of sines was proportional. You would have like sine of A over A, sine of B over B. And in this case, it's just one big equation that goes all the way across. All right. Let's do number 19. We're going to use this picture to find the value of theta. Okay, let's stop for just a second and think about what we have, and let's label it. I have 22 right here. It is across from big A, so it must be little a. I have 22 right here. It's across from big B, so it must be little b. I have 10 right here, and it's across from big C, so it must be little c. And that theta is in the corner. It is an angle, and because it is an angle, I'm looking for the measurement of an angle, which is a capital letter. I am looking for the measure of angle C. You can call it capital C, you can call it theta. Either way will work. Because we are looking for C, we're going to pick the formula that starts with the letter C. Now, let me point out, you're looking for capital C. But this formula, the bottom one right here, is the only one of these 3 that has a capital C in it. So we'll pick it. And it happens to start with a little c. If I'm looking for a C, uppercase or lowercase, use this formula. If I'm looking for a B, uppercase or lowercase, use this formula. If I'm looking for an A, you know what I'm about to say, uppercase or lowercase, use the top formula. So, looking for capital C, we're going to write this formula. This one is going to be very different. C squared equals A squared plus B squared minus 2AB cosine capital C. I'll put that in parentheses. Let's start filling in our numbers. This one is different. The last one, we did not know little c, and our variable was pretty much isolated the whole time. Now our variable is going to be here, and we're going to have to work around that. It's going to be a mess. We know little c is 10. We know little a is 22. We know little b is also 22. Oops. There we go. Squeeze that in there. Minus 2a, b, cosine capital C. Wow. We have to solve this thing for C. This is going to get interesting. Okay, let's start with the easiest thing. What's 10 squared? Duh. Got it. Okay, let me tell you what not to do. Do not do what I'm about to do. Well, I'm not going to do it. Do not, excuse me, do not type all that in your calculator. Don't do it. Here's the reason why. All of this right here is one big term. We're going to figure out what all this is. Well, we're going to figure out what all this is and put that at the end of it. Before we get there, let's do this. These two are two separate terms, but they are like terms. So we're going to type that in. 22 squared plus 22 squared. 968. minus whatever I'm about to get from this. Now, I don't know what this part is, so I'm going to use my calculator to find the value of this right here. And then I'm going to tack that onto the end of it. I'll go ahead and tell you. I'll show you in the calculator, but you know how to use a calculator. It's going to be that answer right there. Not a coincidence. That doesn't always happen. But because both of these sides were the same, both of them were 22, it's going to happen this time. So this is minus 968. Don't forget this part had a cosine C on it. You can put it in parentheses if you like. Okay. Again, here's what not to do. Do not combine these two. These are not like terms. Don't tell me that 968 minus 968 is 0. Not right now, it's not, because this one is attached to the cosine. If we are solving for C, then we are going to need to subtract 968 from both sides. Negative 868 equals negative 968 times the cosine of C. We're still looking for the measurement of angle C. Don't let that cosine make you angry. It's not going to kill you. We are going to divide now. We're looking for the C, and this guy is sitting in the front, and it is multiplied, so we have to do the opposite of multiplication. So we will now divide by negative 968. Divide by negative 968. And we'll cancel those out. I'm running out of room, so I'm going to bring it over here. Over here, we're going to have the cosine of C, because those two divided out. Over here, I don't know what we have. I know it's positive. Knowing it's positive, I'm not even going to worry about it, the negative signs. There we go. We have point. Now, some of y'all are going to round that off, and that's fantastic. Go for it. I'm going to write the whole thing out. 0.89669. I'll stop there. I'm not going to write the whole thing. Now, I said some of you are going to round it off. If you want to round it off on your paper, feel free. But you better carry this entire decimal with you. Carry that whole decimal through on your calculations. If I'm looking for the measurement of angle C, we went over this previously. When I'm looking for the measurement of an angle, I'm not going to use cosine. I'm going to use inverse cosine. I'm going to write down what happens in the calculator. Inverse cosine is the cosine to the negative 1 of my last answer, 669. And that's going to give me C. Second, an answer. I'm going to close those parentheses just for fun. Now, at this point, I will round, and I'm going to use the nearest degree. 26 degrees. There we go. Okay, I'm going to move the calculator, and I'm going to walk you through this problem very quickly again, just to make sure you understand it. I was looking for capital C, so I picked the formula that has a C in it, which starts with a C. We filled in the numbers, and then, after filling in the numbers, we put these two together to make that. We figured out what this part was, and we realized that it's attached to the cosine of C, so we put that. Subtract, divide. We ended up with this part, and we do the inverse cosine. Okay, let's do the next one. You and some friends are going to wrestle in the yard. You're going to tie a rope around 3 trees, make a triangular wrestling rink. Stop right there. Draw a triangle. The elm tree and the maple tree. Elm, my word, I misspelled it. And maple. I don't care where you put them, but if you want to be consistent with me, then do what I have. The elm tree and the maple tree, 12 feet apart. We'll put 12 feet right there. Ignore that bell. The elm tree and the spruce tree are 16 feet apart. And the maple and spruce tree, grammatically that should say trees, are 14 feet apart. Draw a picture to represent this scenario. Well, we did that. Okay, I'm going to stop right here before I even try to figure out where I'm going with this whole thing. I know it's going to involve the law of cosines, and I know my formula. Excuse me. Sorry. Sudden cough came on me. I know it's going to involve the law of cosines, and I know I'm going to need these formulas, and you know, I can make up my own formulas with E and M and S, and I'm not going to confuse everybody in the world, so let's just stop right here and let's relabel a couple things. Arbitrarily, doesn't matter how you pick it, I'm just going to call this one A, I'm going to call this one B, and I'm going to call this one C. You can just pick them like that, it doesn't matter what's what. If you want to be consistent with me, then do what I'm doing. So, what's the angle of the rope at the elm tree? Well, I'm looking for the angle of the rope at the elm tree. That would be this right here. Let's start labeling what we know. We know this. Is that little a, little b, or little c? Ah, good guess, I hope. It's across from big A, so it's little a. Across from big B is little b. Across from big C is little c. So now we have to decide, what am I looking for? Well, I know the sides. I don't care about these two angles. The only angle I care about is this one right here, and that is big A. So we're going to use the formula that starts with the letter A. A squared equals B squared plus C squared minus 2BC cosine of capital A. Okay, let's plug some stuff in here. At this point, we know everything except A, capital A, so we'll just start filling some numbers in. We've labeled them all, so this part shouldn't be too hard. There's little a, there's little b, there's little c, little b again, little c again, cosine of big A. There we go. Okay, here's what to do and what not to do. First thing, let's do the easy part. 14 squared. I'd like to think that you know this one off the top of your head. That would be 196. Now what we need to do is combine these two terms right here. Why do we combine those two? Because they're like terms. Like terms have the same variables with, and doesn't apply in this case, but same variables with the same exponents. Neither of these have a variable, so we can put them together. I cannot go combining this term, and all that, because that one has a variable on it. Okay? So this is going to happen separately. 16 squared and 12 squared. I do believe that is 400, unless I'm horribly mistaken. 16 squared plus 12 squared should be, yeah, 400. 400 minus. I'll warn you about this minus sign. See, I know this is going to be negative because none of the rest of these are negative. Now, some of you are probably going to type negative 2 times 16 times 12, and that's fantastic. Go for it. But keep in mind that it's really negative right there. A lot of people get negatives and subtraction mixed up. They're the same thing, essentially, depending on what you're doing. There we go. Okay. It is very common at this point for students to look at this and say, well, 400 minus 384. No, 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 no. Don't do this. If you do this, if you were doing this right now, I want you to pick up your calculator and hit yourself as hard as you can in your head. Don't do that. This is not 16. No, it is not. Don't even try it. No. I want you to raise your hand and confess your sins to the class if you're doing this right now. This guy is connected to the cosine. This one is not a like term with this term. These are two separate things. Even though these look like numbers that should be subtracting, don't subtract it. Don't you do it. And I really hope you wouldn't have to type that in the calculator anyway. We're going to subtract 400 from both sides, because at this point we're solving for A. Don't you go putting those together. I know we got to put those together, and well, his life was a mess. Okay, those cancel. On this side we are left with negative 384 times the cosine of A. On this side we have negative 204. Okay, we're solving for A. Let's divide. We're going to divide by negative 384. And we're going to cancel both of those. That's going to leave us with the cosine of A equal to whatever we get when we divide these. Now let's be realistic. We know it's positive, so you can leave the negative signs off in your calculator if you want to. 204 divided by 384 is that right there, 0.53125. Okay, similar to what we did up here. We need to do the inverse cosine. We're looking for the measurement of A, so we got to get rid of a cosine. Next step in the calculator is going to look like this, 0.53125, and that's equal to A. My handwriting got suddenly sloppy. Inverse cosine of my last answer. We'll round that to the nearest degree. We are now finished. The angle at the elm tree is a 58-degree angle. There we go. For what it matters, this is almost an equilateral triangle. Oops. Almost equilateral. Not exactly, but pretty close. So this is 58 degrees. These sides are about the same-ish. This angle's close to 60. This will be almost equilateral.